I'm ready.
Let me know if that's working.
Yep,
We're on. Okay. Now that we've got that, well, deserved recognition, those guys out of the way. Good evening again and welcome. Thank you for bearing with us with our many changes of venue. I know it's frustrating, but we do appreciate you sticking with us. We are doing our best to nail it down to one place. I can see some new people. Who is new tonight? Whose first session is today? 3, 4. Okay, well, as you probably might have gathered, this is the 4th session of our sort of rebooted, what do you want to call it, semester? I don't know, course. So we are, as you might expect, sort of going on from the first couple of weeks. So if you want to have a look at what we covered in the first 3 weeks, all these slides are on our GitHub, the PDFs, and also the videos. You can listen to me yakking on for 2 hours on YouTube. So our YouTube is it C++ London or CPP London?
The URL?
No, the
Hashtag?
No, the YouTube username.
Oh, CPP London.
It's CPP London on
YouTube.
On
Sorry.
YouTube. So if you want to search for us and catch up, then that'd be great. So standard first slide, but for everybody who's new, we do like hearing from you. We have this Slack channel, or there's a CPP Lang Slack channel, and we've got our own room in it. UG, UK, CPP London Uni. Easy to remember that one. So you technically need an invitation to join the CPP Lang Slack, and it's really hard, it's really selective. You just go to that email address, go to that website and put your email address in, and you'll get an invitation beamed straight to you, and then you can join us and you can chat to us 24 hours a day. We might not respond 24 hours a day, but you're welcome to send messages anyway. Also for the new guys, this is the book we'll be using. We haven't done very much with it yet, but we will do a bit more today. This is it. It's a fairly weighty thing. I assume by now most people hopefully have a copy. Or somebody next to you, near you, has a copy. There aren't too many sitting on the desk, but they're probably just in your bag, right? Weighs a ton lifting it up. So you will need it towards the end of the session. Right, so last week, just to refresh your memories, this is what we covered, which was quite a bit, really, wasn't it? We got everybody set up with C-Line, which is the IDE development environment we'll be using for this course, and a compiler as well. And then we looked at sort of the mechanics of how to compile C++ programs. And we talked about how a compiler works in very sort of high-level terms, how to compile from the command line, the idea of separate compilation, if you remember those diagrams from last week. Then we talked about using libraries and header files and using hash include to bring your header files into your program. Is that all ringing a bell, or has it been a long week? That's all fine? Yeah. Right, more exciting stuff this week. I'm going to talk about value semantics, which I've been so the first 2 items I've been promising to talk to you about for about 2 weeks. Now I'm finally going to do it. We're going to talk about scope and what scope means. We're going to have a basic introduction to object lifetimes. It's really quite an involved subject, but we're going to have the headline features, and then we're going to get onto the meat, the good stuff, the things you can actually use to write slightly more interesting programs than we've done so far. So we're going to talk about if statements, and we're going to talk about the various forms of loops there are in C++. These are really the bread and butter of writing programs. I think most of you are familiar with some other programming languages, you don't get very far without these things. Does that sound good? Yeah? Okay. Giacomo, you look like you're very, very tall. Yeah. Right, let's talk about value semantics.
You have a giant in a room.
Yeah. You could. There is a spare chair at the back if you didn't want to be quite so high.
Yeah, but there is a plug here.
No, but I mean, you could swap your stool for the chair.
Are we in a block or not? Okay. I thought they were all together. Fine.
Sorry, I just didn't know if you were blocking the view of the people behind.
That was like all together.
Probably for the best. Well, let's talk about value semantics. Does anybody know what that means? Excellent. Means I get to define the term for you. Well, the first thing to say is that C++ is kind of unusual amongst modern-day programming languages in that it uses value semantics really as much as possible. Whereas most other languages, so Java and most of C#, Swift for classes, Python, JavaScript, they all use what are called reference semantics. With C++, we do the opposite, with value semantics. And as good a definition as any, I suppose, is that it means that copies of variables are distinct. So you think about how an int works in most programming languages, an integer. When you copy it, if you copy that, you change the value of the original, the value of the copy doesn't change. They're two independent objects. So, seeing blank faces, that's fine, because this is something that's perhaps quite different to programming languages that you've used in the past. So, the idea is that the value of an object, what it is distinct from its identity. So, some programming languages let you compare both. You can have those double equals and triple equals. In C++, we talk about its value. And the way to think about it is imagine I had a magic machine that would produce a new version of whatever I put into it. Right, so, I don't know, first thing that comes to my mind, imagine a shirt. Just a shirt, plain white t-shirt. If I go into a shop and there's another one on the shelf, exact same one, that's not physically the same object, but all of its properties are the same. So you look at those two t-shirts and you say these are the same, but they're not physically one item. Right? They're two distinct objects, but their properties are identical. They're the same size, they're the same color, they're the same price. They're two distinct objects, but their properties are the same. And those properties are what we talk about when we talk about the value of an object. So back to this magical machine that can, like the replicator in Star Trek that can just create a clone of anything I put in it. So I put my shirt into this machine and I get an identical shirt out, but it's not the same object. We've created a copy. And then if I get my marker pen and I scribble over one shirt, it doesn't affect the other shirt because it's a distinct object.
That happens through assignment, not anything else.
Assignment is one way to do it. Later we'll get on to talk about methods on objects which can change an object's properties.
Yeah.
So to elaborate what you said, actually concrete.
Yeah.
Let's say if your method takes in an input array.
Yes.
Yeah. And in C++, if you say my copy equals input array, and you sort on the input array, my copy remains the same order as the original order.
Precisely.
However, if you do it in Python or some other language you know, you do it exactly that. Say input array equals my array, sort input array, suddenly
Yeah.
What advantage and disadvantage
You get to choose in C++, don't you? You get to choose
Well,
whether you...
first of all, that is exactly true, because you can use references in C++. We were going to do it today, but it turned out I packed far too much in for the rest of the time, so that's moved to next week. But references are really a core feature of C++. So you can use references in C++ if you want to, and you will for a lot of purposes. But what's the advantage? The advantage is that with value semantics, you can most of the time look at a piece of code in isolation and know exactly what's going on. You can know that no other piece of code over there, possibly in another thread or whatever, is going to affect the function, the little block of code that you're looking at. So that's the major advantage of value semantics.
What's the advantage of using references?
The advantage of using references is you don't have these copies going around. So if you imagine you were talking about an array, that if your array had 10 million things in it, then copying that is going to create another array, a separate object, a magic machine that clones things. It's going to create a second object.
It's quicker for a computer to check in a lot of situations whether an object has the same reference than it is to check whether the object has the same properties. You need to check for equality.
I am
Sorry.
extremely confused.
Okay.
Sorry. Like, because what do you mean by copy? Because I understood that, for example, we declare something. For example, A at the beginning, and at some point we call A again, but we can change. I'm not sure I understand the right word, because I thought once we declare something, we cannot change.
No, that's only the case when you have a const variable, which we talked about a couple of weeks ago. But let's say you just say int a equals 3.
Yeah.
Then a represents an integer, its value is 3.
Yeah.
Then later on in your program, you say a equals 5. Now you've changed the value of that integer.
But how can we track, like, the value? Because, like you said, many people are gonna work on the same code, and it's just gonna be a mess because you don't know what maybe the others have done with the same value, and there might be like 100 copies.
Unit testing.
Well,
Yeah.
there's testing comes into that, but also, as we'll go on to talk about in just a moment, but if you reduce the scope of your variable so that you can see the entire block of code where this variable is valid, then you can have a very good idea of what's going on with it. You know that somebody else's 1,000 lines in the middle of the file isn't going to change what you expect it to be. You look like you're about to say something, or are you just sort of taking it in?
So
Yeah. No, okay.
So just if you have it, like I said, for your example, int a equals 3,
Yeah.
then a equals 5. Does
Yeah.
that mean you have an a equals 3 and a 5?
No. So if we say int a equals 3, did I say to start with? That means we're creating a new integer. We're introducing a variable whose name is a. And when we later on say a equals 5, we are assigning to it. We are changing the value of that existing variable.
Yeah.
So I've got an example on the next slide that will perhaps make it a bit clearer. Yeah.
I just want to make a clarifying point, mostly about you talk about how JavaScript also has reference semantics. In the example that you talked about, when you have a method and you're passing in an object to it, that actually doesn't apply in JavaScript's case, because what it does is whenever you pass in something as a parameter, it creates the same way C++ creates something that's completely unconnected. JavaScript does the same thing. I just wanted to
Okay, well, that's what you get for giving an example of a language I only know the slightest bit about. So
It's references being passed by value. So the value of the reference itself is a value, and that value is copied. So think of it as like a magical pointer, right?
Oh,
I copy a
like
pointer.
Java.
Same as Java, yeah. Like you copy the pointer value, but the object is just a pointer to an object. So when it's a reference type, that's what happens.
This is really good, by the way, because this is a very important concept to sort of get your head around. And like I say, it is quite different from how you think about things in other languages. So questions are great.
Going back to your one, value 3. I mean, that doesn't. So just looking at trying to correlate the 5 and the 3 with the second bullet point. So it means are you copying when you change a value? Does the 3 disappear because it's not changing? Will not affect the original variable.
Okay, so if you think about how this actually looks in computer memory, so an int will be 32 bits, 32 ones and zeros, and there's a particular layout of ones and zeros that represents 3.
Yep.
So when you say this thing equals 5, it changes the layout of those ones and zeros to the layout that represents 5.
Yeah.
I mean, maybe another way to look at it is it's a point in time, right? Any computer program, each line of that code represents a point in time. So you have int a equals 5. Okay, or did you say 3 or 5?
3.
3. So int a equals 3, right? That's a point in time. So at the point in time where that executes, you now have this variable a and it's 3. Later on, maybe the very next line, a equals 5. We've already declared it. So now at this point in time, the space in the computer, the register or memory, that variable is representing is just changing to 5 at that point in time.
Right.
So previously in the past it was 3, now it's 5.
That's not making a copy.
That's not making a copy. If you did int b equals a, then you now have new space in memory or in the CPU's registers that are now going to have the same value, but not in the same place. You have 2 places now, actually, 2 variables, 2 places.
Yeah, and then if you change the value of b, you're not changing the value of a.
Right, it's a separate place.
Yeah. So I've got an example which might hopefully solidify things a bit rather than talking in the abstract. I've gone for 1 this time. Should have remembered that. So we're declaring a variable a whose type is int, and we're setting its initial value equal to 1. Everybody happy with this line of code? Yeah, good. So what's happening here? Somebody tell me. This second line.
You're making a copy.
You're declaring b, and then you're making b equal a.
Yes.
Which is a copy.
So we are copying a. We're creating a new variable b whose properties, in this case its numeric value, are the same as a's.
But don't have the same address.
No, that's the really important thing. These are 2 completely distinct objects in memory. Okay, they don't refer to the same object or anything like that. There are no references involved here, no pointers. These are 2 completely independent variables in memory.
So at that point in time, they're the same value.
Exactly.
And from then on, they go off their own paths and have whatever value you give.
You got it.
Okay.
So at this point in time, as Ollie said, b has the value 1. Now let's move on. Let's now set a equal to 42. So we're changing the value of a, the properties of a, changing the value of a. This is the equivalent of taking one of your t-shirts and dyeing it purple. Right, you've got 2 shirts. You dye one purple, the other one doesn't magically become purple. So b still has value 1. We've changed a, but b is independent. Does that make sense?
No. But like, what about a? I mean, I understood with the copy that a technically, I think you say you already know, but technically it has 42 and 1.
No.
Because
No,
they don't
no.
point at the same reference.
I mean, I don't know if you read the book, Mr. Strostrup, he suggested like explanation. Think about the A as a container of type A, so it accepts things in type A. And so you store the... type in, sorry. So you store something, you put a token, a coin, whatever, yes? Number 1. Now, if you want to put some, so when you first do the initialization, so you create a box and you put the value 1. Now, if you want to put the value 42, you have to first destroy the 1 and put another coin with the value of 42. That's how he explained this.
Okay.
Maybe. So go on. Okay. Maybe think of them as like a billboard, right? So A is a billboard, and we paper up 1 onto it. And then B is a billboard, and the guy just looks at what A is and papers that up on the other billboard. And then when you get 42, he just papers over the 1 with 42. So now it says 42. The fact, it's not strictly like that, because you can't tear the paper down and get the 1 back once it's gone. But
I don't understand better.
Okay.
Does, because you spoke about time, I think I'm thinking too much for that, but does the compiler or anything remember that at some point A was 1? No? Okay.
So B doesn't update, it stays as the original as 1. Is that
Exactly.
That's
That's exactly the case. So B is.
it doesn't matter how many times later you change B, you change A, B is still going to be the original.
Correct. Yeah, absolutely. So they're independent. They're in separate pieces of memory. Changing one will not change the other. No matter how many times we could say A is 43, 44, 45, whatever we liked. B will still remain 1 until we change it. Oh, sorry.
It's because what happens if we write int b equal a after we wrote a equal b? A equal 42.
Okay, so what happens if down here we say B equals A?
Yeah.
What do you think will happen?
I think it became 42. B became 42. So just about which kind of line came first.
Yeah. So you're absolutely right. If down here we say again B equals A, not int B equals A, because if we put the int word in the front, that means we're declaring a new variable. So this is saying there's a new variable called A. This is changing the value of our existing variable A. So if we said now B equals A, that's an assignment. And what it means is that we're copying A's value into B. So we're updating B from the value of A, but we're not making them point to the same bit of memory. They're still completely independent. So let's look at a different example. Everybody's favourite standard string. If these 5 characters bother you, then just ignore them. This is a string. String is a bit of text in programming. It's called S, and we're initializing it with hello. Now we've got a second one, which we're initializing with world. Independent, separate variables. So now we have an interesting line. So S plus equals S2. So does everyone know what plus equals does?
Concatenations. No, just
In this case, concatenation is what it does. Yes. So you can use it on ints, for example. It will add that one, set that one equal to its old value plus that. But for strings, it concatenates the 2 strings together. So what this means is that S now has the value hello world. So it has these 2 strings, these 2 glued together. Right? So my question is, as of here, what is the value of S2? What does S2 contain?
It's the same.
World. Absolutely. Awesome. That's great.
For example, just to be sure that I understood correctly, if we were to resume like very basically again, for example, an xp, so life, would be like the variable. So let's say we start at 100, so all good, and then at some point we just go down, I don't know, we got a tag or something, and we drop to 0, like, and blah blah blah. But yeah, the computer is not gonna remember that at some point it was 100 because now it's at 0.
Yeah. Exactly.
Okay, good.
If you want to remember a previous state, that's up to you as the person writing the code to make a new object to store the value in before you go ahead and overwrite it. Like if I'm working on a Word doc, right, and I hit save, that's it. The file's now saved at the state it's in when I edited it. If I'm halfway through editing and I'm like, oh, maybe I might want to go back to that at some point for a different version, I have to save a separate file for that, right? So you as the programmer have to do that.
Oh, we should have thought of that analogy before. Yeah.
I have a question, like if we console log string s before to do s plus equal s2,
Up here.
we will just get hello. And
Yes.
after, if we apply s,
So if you print s here,
yes,
then you'll get the value that it has there.
Yeah.
So you'll print hello.
so only after.
So after we've made this assignment, if we print s now, after on this line or down here after the comments, print s now, it'll print out hello world.
So if a function is going to take s, it's going to take the second s, like s plus equal s2.
Well, it depends when you call your function.
After.
So if you call your function down here, then it'll receive the value that s has down here, which is hello world. Yeah.
Thank you.
I don't mean to be like nitpicking, but I think there are quite a few people who are from other languages. Right? I think on the basic level, almost every language is doing that on the basic type.
Yes, for things like ints, yes.
So if you do this on JavaScript, it's exactly the same behavior.
Yeah.
It is exactly the same as Java.
It's not for objects in JavaScript.
So
Yeah.
when it's complex, like an array, that's what I was saying,
Yeah.
when you sort an array or you sort a list or something that has numbers, then this deep copy becomes very significant.
Yes.
So I just want to mention that, so I myself not getting
Yeah,
confused
no,
about
you're absolutely right. Yeah. So this behaves like, I don't know what you're familiar with, structs in C# or basic numeric types. I've forgotten what they're called in Java. Fundamental types, they call
Primitives.
them? Primitives, yeah. Yeah. Deep copy semantics. So now, let's talk about calling functions. So C++, like C, by default, we have pass by value. So other programming languages, well, it's a bit complicated in Java. Because Java does pass by value, but it sort of looks like it doesn't. Other languages, Fortran passes by reference. There you go, that's one that came to mind. Python as well. But C++ passes its arguments to functions by value. And what this means is that your function parameter, that's the bit that's in the top of your function in the round brackets, that is an independent copy. It's a new variable that is independent of the thing that you pass to it. So we've just seen how to do copies for local variables. That's exactly what happens when you pass a value to a function. You pass an object to a function, it gets copied into that function. And this means that inside that function, if you change the value of the parameter, it doesn't affect the original object. Which again, is quite different to how other programming languages work when it comes to class types and things. It's exactly how most programming languages work for primitive types like ints. And again, when we return something from a function, what we return, conceptually at least, optimization gets involved, but conceptually at least, we're returning a copy of the thing. If we say return A, then we'll return a copy of that variable to the person who called our function.
So if you want to modify your, say, vector in a function,
Yes.
you have to put my vector equals function called my vector, and then in return the vector
You don't have to do it, because what you would do in that situation is you would use references, but we're not going to talk about that this week. But there is a way to, you can opt into using references, right? So C++ does support passing by reference, but it's not the default. You have to do something special. So you've got to add a little and character in order to activate passing by reference. But if you don't do that, if you just do the default, you're going to get passing by value. So again, this is sort of wordy, and it's perhaps easier to see by an example. So this is just a bit of a revision on header files, implementation files as well. So what's this? This whole line of code, what is it? Yeah, I sort of gave you a clue there. This is a function declaration. So this declares, it says this function exists. It doesn't say anything about what the function does inside. It just says this function exists. So what's the name of this function? Add one. Excellent. How many parameters does this function take? Which is of type? And this function returns? Yes.
What's the correct name of naming this? The underline or the joint and the capital letter?
Oh, well, that's
Just
one of
because
one of those endless arguments of style.
So we discussed tabs versus spaces.
Yeah. I prefer snake case. That's why I write all my this long-winded everything lowercase with underscores in the middle. I call it snake case.
Which one is the Hungarian?
Oh, that's different.
That would be like DW, but DWI.
Yeah.
DW.
Some people prefer snake case. Some people prefer camel case. So if you're using JavaScript or Java or JavaScript, those sorts of languages, they have a different convention for how you write function names. This is the way I prefer, so that's what we're going with. Sorry. Anyway, this declares a function. So we put this in a header file, if you remember from last week. And then somewhere else, somewhere where we use this code, some other implementation file miles away that happens to have included this header. We declare a variable, an int j, and we initialize it with 42. And now we call this add1 function. Forget about this bit for a moment. This is how we call a function. So we write its name, round brackets, and the thing we want to pass to the function. So in this case, we've got the declaration up here. We see that add1 has a parameter, which is of type int. The name doesn't really matter. It's of type int. So we have to pass it an int. And it just so happens we've got one here. So we pass it to an int. We pass the int to our add1 function. Just a bit of terminology, by the way. I don't always get this right, but I try to. These things in the declaration, these are parameters. The things you pass to it are arguments. So I tend to mix and match a little bit, but that's sort of the technically correct. Unless you're like doing hardcore computer science, in which case they call them like formula arguments, not actual arguments. I don't know. Anyway. But this function returns an int as well. So when we call this function, it's going to give us an int back. We assume from the name that it's the one we gave it. with 1 added to it. It'd be annoying if add1 did something else, right? So this function returns an int. So what we do is we declare a new variable. I've called it ret, because it's the value that was returned. We declare a new variable called ret, and we initialize it with the return value of this function. Now I've used auto here for no particular reason other than to remind you that it exists. Auto is type inference, the same as var in other languages. It means that we infer the type of this variable from its initializer. In this case, its initializer is the return value of this function, which is an int, so ret is going to have type int.
It basically says to the compiler, figure it out for me.
Yeah. So here's the key thing about passing by value, is that add1 operates on a copy of j. So within our function, that we'll see in a moment, the variable I is a distinct copy of j, a distinct variable, lives somewhere else in memory. So after this function call, when we get down here on this line, j still has value 42. We haven't changed j. We haven't said j equals anything. We haven't changed j in any way. J still has value 42. Same value we gave it to start with. Ret, on the other hand, has value 43. So now imagine we're in another implementation file. We're going to write the definition of our function. Again, this is just a bit of a revision from last week about definitions and declarations and header files and implementation files. So to write a definition, we write this again, but instead of the semicolon, we put a pair of curly braces, and inside those curly braces is the body of the function. So within this function, what we do is we take our I, and we say I plus equals 1. Right, but the absolute key thing is that this I that we're working on down here is a different object to the thing we passed to the function. And then we return I from the function. And that, again, creates a new copy, which is what we initialize ret with.
So your returned I will be different again to the I that exists inside the function?
In principle, at least, yes. Again, like I say, compiler optimizations get involved, but that's yes.
Yeah, but technically I in the declaration has no value.
Up here, it's just a label, right? So if you think about it, if this had several parameters, then you could give them meaningful names so that somebody who just looks at the definition knows what those parameters are supposed to be.
Yeah, but why do you say that it's a copy? Like, you say something like, I there is different from the one in declaration.
No. I said it's different to J. So this line here, all this says is a function called add1 exists. It doesn't say anything about what the function does. It just says it exists, and this is the types it takes. So that's passing by value. That sort of makes sense to people? Yeah? I like this. Getting nods around the room. Makes a change for the first couple of weeks. Right, well, if everybody's got that, now's the time to prove it. So if you're here last week, don't worry about header files and implementation files for this little exercise you can do. If you create a new project in C-Line, it's just going to give you a main file. You can just do everything in the one file. a chance to prove you earned that certificate.
He was actually asking us what the variable is active.
You're allowed to talk, by the way. This isn't school.
If you need any help as well,
Yeah.
then speak up. I'll happily come round. Got an interesting guy on.
Sorry?
Got an interesting guy on YouTube. Seems to know Python because they took umbrage for reference in statement variables will pass by value, which technically it's just a reference itself is passed by value. Yeah.
Right, the values are pointers.
Effectively, yeah. Pointers, yeah. They did ask a good question. They said, can I use auto for literal? Can I use the word literal? Is that right? Yeah.
And you can, but you get a horrible type with strings, which is why.
Well, it was auto x equals 42, for example, would be
Isn't it?
just
That's
a
fine.
standard.
Yeah. It's
If you did 42 UL, it would be on the same block. Yeah, obviously.
it's const car style, I guess. Yeah.
Everybody needs help, just raise your hand.
We go around there. That's similar. What I've asked
You broke the YouTube.
Say hello, which is parameter of type standard string.
Or I wrote key.
Okay, so that's a string.
Okay, auto name.
Right, but in this case,
also
I want you to make this function return a string as well.
Cool.
Oh,
So
nice.
void,
Oh,
if
it's
you remember
something
these,
else. Okay.
doesn't return a value. So we have to change void to say the different, say the type is. Yep.
No.
Yep, that's good.
This line.
Well, what have I asked you to do?
Well, you
Say
see,
modify.
I mean, if you prefer
Name.
to studio, you don't have to.
I added the string hello with a space.
I can show you that easy if you want to learn it.
Yeah. So we saw how to.
Cool. So you've got the CPP stuff.
Yeah.
Click on main.cpp, that's the source code. Don't regret the build folder.
So this line is going to print it. But that's not what I wanted to do.
Click in this little drop down. Do you get the compilers? If you're doing this on Windows, did it ask you to install the compilers and stuff?
All right, that's pretty much what I got. So what I was after you to do was to use that plus equals again to modify very
I think
what I wanted to make clear was that even if you modify the name, it wouldn't copy. So modify it should be has no effect on the original value.
Yeah, you're good.
You don't. You can just change those.
So not see like the ring function reduce. Sharp,
so then, after you use this variable,
you could just use Visual Studio.
So
Do it just to a console application. Give it
what we want to do, we don't need this.
Doesn't matter if it's and you send a flow, it works.
Yeah.
No idea.
We need to create a new variable to save the result of So this function, when you call this function, it's going to give you that, a new string.
Can I just say this one?
So you can do standard string new name equals. Say
it's not part of my job, no.
You can say string new name or whatever you want to call it. So create a new variable.
Yeah.
Let's start from the at the top. You can do either just to make sure that there is a function, or you can try the whole function.
Yeah, that's
The easiest thing to do is just press go and see what goes wrong.
No, that's absolutely right.
What's the first week of the return type? So what's the return type?
It's printing Dora because that's on this third line.
Strange. So you say strange. Above the main, above the
Oh, sorry, last one. Yeah.
She saved it to this variable new name, so she could just the idea was to print new name as well.
And by the way, you would have to add as well the include string.
I know, so
Everyone has a different way of solving, even the simplest.
yeah.
5 lines of code, everyone has different.
Well, the thing is with the exercises, I started off being very, very explicit with exactly, and just try and reduce the amount of information I give you at the start. So by the third exercise today, which is pretty tricky, it's just, this is the problem you solve it.
Oh, okay, right.
So that's also the homework I have, so I'm not expecting people to do it.
Okay, so you run through it, right. This is fine.
So what's after this? Hello.
So decide define the string. Yeah. Please give me your name. It says please give me your name.
What mean? See.
See it. Comma and then suggest see it promise. I've got promising. It's asked there is a function called there. Has my identification to their say hello. Say hello with the name I just given it. That's just that's just the yeah, so I know where it jumps out.
Yeah, at first I didn't.
But when it gets to here, you can have to say hello. So it comes up here.
So what you're saying is saying
Why
word
do you
has like
range
and as well names. I like that.
First way you did it was
and then need semicolon at the end. Closing there. Just now, you have to call the function variable.
Well, this is the thing, I did everything. It's just that as I spread it out, because you have directions.
So then print hello, there's some space in Java, you say and then the frame on the next slide. Yeah, because you see that's this one is the hello tag, yeah, is the first. If you do that,
Oh, because
it's like you have to do it, you have two pieces of paper.
yeah,
Something like
what
this.
we need to do is put take your top line. TP is to the we're discussing so you need to return you don't need to yeah, it's just like that.
Comma. So like a like a top one, yeah.
You don't need this.
That's it, like a yes, like that. Yeah, try print.
Because they're asking to, because they actually want you to just go and print in a different way. Meaning they're asking to change that password address.
That's contained because in some scenarios because that's why I have function storage of that one. So that concept that definitely this is prototype original the function. The function is going to ignore elements when we are asking everything. So this is quite contiguous to the point where that point will
yeah, that's what I'm doing here.
Yeah. Hello, how are you getting on? You okay?
Yeah.
You okay?
Yeah.
Okay, let me help you. Let me help you to unconfuse you.
So you don't know what it is except Visual Studio.
Okay, let me Visual Studio
The best thing is not to declare a variable unless you know what you want to do. So if I example that way, it doesn't make sense because you can just create a variable at the point when you say,
I promise you, there is a function which will do something, or because it's a short function, you can use straight away the whole function. So go to the line 2. Line 2.
I mean,
first we need to put, before we actually do that, we need to include the string. So you do the hash include.
If you get to the same situation,
You know what the hash include means? You have a simple program, yes? And the compiler needs to know lots of things. So the hash include, like IOS means include my program, copy lots of other people's code, which will, it's like that, which does this stuff for me. So we will do include the bottom one, yes, the bottom one include, and then the string. Just type word string. Okay, so go to the end and then press enter. So we say, okay, include the string to all the operations. Make one space and one, so it's not so compact.
This is the same.
So the first one is we need to use function type. First part is the return type. So we say it's like we return string. So you say std string. std means it's standard. Then column function as a scope operator string, so you can use the tab. Now space. Now what you need to say is the name of it.
So if you assign a default value, don't even create a variable.
Open bracket. This you need to put your equals
very well practiced. This is a practice from C and this is why in C++ you can create a because that was a C18 wherever 84 or something.
And then space.
You were forced to create all variables
the container. So let's say function.
And then there was a problem because, for example, a short thing like X, G, or wherever, or iterator, I will then, assign everything to the variable, and at some point, so we can open the braces.
But yes, so is
I personally
go for 30 seconds.
So what we're doing here, we need to, because it's a basic function, so we will return straight away. So we can have what
If I did
press tab to complete. Now we will say hello. Say open the close. Say hello.
No, you can use this only one case. when something is for C++
space as well, so the space hello and the name.
Okay.
Yeah.
A brackets 10.
So simplicity, so that will print out the
No,
hello
no,
with space. Now come outside the
that's no, that's in that case, because at that point it's not
and now we want
that
to
this is either integer
okay.
or this is a function operation. Yeah, but this is the only case as far as I know. This is the only case
Because
that
we
I
finished that's it. Now let's go to the line number 8. And you can press shift and then
I guess, yes, some people might say that.
yeah, I mean, you know, a lot of people don't switch from C into C because they just case behind those.
Yeah,
and one more thing about brackets.
so now we need a string variable. Yes. So it's
Alright.
std.
How are we doing, ladies and gents?
Column string press enter.
Yes, so in that case, yes, we are right, but
so that's the name of the view box. Yeah, so you can now open the curly braces and
with the curly braces, that basically
and then
so this is why for some people this is quite ambiguous because this is a style.
So if we that's fine. Now go to the next line.
But I would never use the rate
So we start printing out std number column.
But you know, depends on what you're writing because if you look for all the
space
and presentation outside, so the idiom or stuff like that, no one is using high level stuff. It's something like that. The C style array is the only thing that
It's alright.
so if you're drawing it down, we can say that you're using the only C primitive, and then when you go up and up, then you're using, you know, all the new fancy stuff.
We don't want to, so that's why I was like, particularly if you're just going to stand around.
That also depends, because if you're using a C-style array, this is the same as hello, you're allocating stuff on the stack rather than in 99% cases it's much faster rather than precisely. Yeah, you need to know the text in old style structure, and you get something like, you know, type a name or something like that. You're just allocating an array that has, for example, 256 character or 1000. This is why the frame has program, because if you pass 1001 characters,
Okay.
Exactly.
Well, I think most people had a good go at that. So here's the way I did it. So we include IOStream, include string. IOStream gives us the facilities to print things out. Includes strings, so we can declare strings. So we've got this function, say hello. Takes a parameter of type standard string, named name. This function returns a standard string. And here we're assigning to this variable. So this variable is introduced here. We're assigning hello plus name. This is a bit of a funny line because we're using it in both places. But what it does is on this side, this is the original value it had here, and then processes this and assigns that result to the value. So that's a perfectly fine thing to do. Very common thing to do. So I just wanted to kind of show an example of that. And then we return this value name. That's the return value of the function. And now down here, in our main function, we declare variable string, named me, initialize it with Tristan. Now we declare another variable, also of type string, which I've called hello me. And we initialize this with the result of a function call call to the function say hello. And we pass this function our variable me. Now inside this function, we're operating on a copy of this variable. So we change it here, but this doesn't affect me. It doesn't bother me. And we can show that because if we print both of these lines out, this one's going to print hello Tristan, and this one's just going to print Tristan. So hopefully most people got something along those lines. Does that all make sense? Wow, that's large text. Does that all make sense? Yep. Right, let's make life more complicated then. Yeah.
Why did you use slash and rather than standard end line?
Standard end line does more than just insert the left and end line. It flushes the output buffer. It's basically slower than just doing slash end. For a trivial program like this, it doesn't make any difference, but using end line, end all, it's just a bit of a bad habit to get into. So in my examples, I try and not do so.
There's a question.
Yes?
Sort of unrelated, but I'm just wondering if, stylistically or efficiency-wise, is there a reason not to go return name equals hello plus name?
No, that's exactly what you would normally do. This was just an example to show that explicitly modifying this variable doesn't change the thing we pass to it because it's a different variable. It's a copy. It's done by value.
Any questions? Everything clear?
All right.
Cool.
Anybody online winking at me?
All these dealing with those if there are.
Excellent. Let's talk about scope then. Who knows what a scope is? What scope means in a value in a programming?
Is the context the space where a variable is allowed to be used?
Perfect. Absolutely. Yeah. It sounds sarcastic when it's just you, but I assumed you were being genuine because that was a perfect answer. So, I mean, technically, a scope is a region of text in our program listing, right? But that's not how we think about it. We think about scopes in terms of variables. And in general, the scope of a variable means that area of our program in which we can refer to that variable. And that's generally from the point at which we declare it, the point at which its name first appears in the program, until we leave the block that it's declared in. Which pretty much means when we hit the closing curly brace, or when we return from a function. Or later when we learn about exceptions, if we leave a function via an exception. When we leave the block by any, whatever means we happen to leave it. And this is a really crucial thing, is we cannot access a variable outside its scope. C++ is very strict about this. So, again, easier to get the hang of, I think. Sorry? You were writing. Oh, sorry.
I think that's just a picture.
That's all right. It's just that we spent a bit longer on that than I had intended, so I was trying to go on. But no, it's fine. So let's have a function definition. My imagination was lacking, so I just called it func. So this is a function definition because there's no semicolon there. It's got the opening curly brace. So we've introduced this new variable I. So I's scope begins here. And we assign to it. This is fine because I exists at this point. We've declared it up here.
Can I ask a question?
Yeah.
If you because it's allowed, you can send just int without the name of the variable.
Yes.
Is there any way to access that variable?
No, if you don't give it a name, you can't refer to it.
Thank you.
Does that make it an R value?
Sorry?
Does that make it an R value?
No.
So what's the point actually of that?
The reason for unnamed variables is because sometimes you want to write a function that has a particular signature. For example, when we're dealing with inheritance, you want to overload a function with a particular signature, but you don't need to use that argument. So you just don't give it a name, and then you don't worry about it.
Okay.
So yes, giving the parameter a name is optional, but if you don't give it a name, you can't refer to it inside your program. It still exists, though, but you can't use it. You can't refer to it in any way.
So it's
So I think somebody asked me in like week 1 or 2. Somebody asked me that question.
Unnamed variable is called then, yes? Or
I-
anonymous variable.
I guess an anonymous variable would be. I'm not sure what the proper name is.
Okay, thanks.
So now we declare a second int called j. Again, I was really lacking in imagination when I wrote this example, wasn't I? And we initialize it with the value 1. Our j scope begins here. Now, when we're in a function, we can declare a new scope wherever we like. We can start a new scope just by writing a curly brace. So we declared a third int, which, sure you're getting this naming scheme now, we've called k. We've initialized it to 42. Now here's the thing, this scope is within the scope of the function. Right? So scopes are nested. So we're still allowed to refer to I because it still exists in this scope. What?
It's great. It's okay, it's good.
Well, kick me on my back or something. Yeah.
What about closure?
What about closures?
Closure. You know, in JavaScript there is closure.
Yeah, we've got lambdas in C++, but we won't worry about those for quite a few weeks. But they do explicitly capture variables by value or by reference. We'll talk about that sometime in the future. So this is fine as well, J is still in scope. We can modify the value of J. But now we close this block. This curly brace matches with this one. We're still within our function definition, but we've closed our inner scope. And at this point, K's scope is over. So if we try down here to say K equals 0, we're going to get an error. The compiler's going to say, I don't know what K you're referring to. There's no K here. K doesn't exist anymore. K stopped existing here. In a very real sense, as we'll see in a moment. And then we have the final curly brace, which closes our function definition, closes the block, and I and J's scope ends at the end there.
Does that mean you have to declare your variable every time you want to use it?
Or you use the
Yeah, you have to declare every variable you want to use somewhere. Yes.
You have to declare it in every function you want to use it.
I'm not sure I follow.
So you're declaring I
Yeah.
in the function.
Yeah.
And then at the end of the function, I no longer exist.
Yes.
But if you want to use I somewhere else in that program, you have to
You
redeclare I.
would pass it in as a function. You can have global variables.
Right. Okay. That's okay.
You can have them.
Yeah.
Generally a bad idea, but
Okay.
they can exist.
Right,
And in that case, the scope is the entire text of the program.
Okay.
Right? They have what's called global scope.
Okay.
Didn't really want to give an example of global
what's-
variables
no,
because it's generally
what's the
seen as
bar-
bad practice.
Okay.
Would this work if you got rid of the void func int I, just an open scope with braces? Presuming you put int I inside the...
Yeah, so if the first line inside said int I equals 0, yes it would, yeah. Exactly the same example.
What's the value of I and J after they leave the curly braces?
Down here?
No, sorry, before that.
Here?
Yeah.
What do you think the value?
I asked whether people will know.
Oh, okay. Well, so at this point here, so just after this curly brace, on this line here, what are the values of I and j?
After the curly brace.
So just here.
0. Yeah. J. I
So-
42.
So it got changed within the sub
Subscope, yeah.
So there you go. So the question is, does that last outside? Does the result of that
That's
change?
what Tom was asking. It's a very good question.
So yes, it does.
Yeah, absolutely. This I and j, this is these are these variables, right? We haven't declared any new I and j. We're modifying these ones. So the modifications, it doesn't undo the modifications when you get here. We've changed the value. So here I is 42 and j is 43, as I heard a couple of people say.
This is legal syntax?
Sorry?
This syntax is legal?
Well, apart from this line is an error. But
No, I mean just to have these curly braces.
yes, you can anywhere inside a function you can open a new block to declare some local variables inside it if you want to do that.
So anonymous blocks behave slightly differently to functions in this sense, then, don't they? Because if you're passing a value into a function as an argument, and you modify that value, it doesn't change on the outside.
So-
and then you're saying, but in this case, we're changing values that we're effectively passing into that anonymous block, and they are changed on the outside.
No, so just
we're making
imagine-
mutations inside the block.
Just imagine that,
outside.
because this is a function declaration, just imagine that it was a block, but right at the top there was a line that said int I, semicolon.
Sure. My question's about the anonymous block. Though.
Yeah.
It seems I'm just trying to figure out because it seems that that block behaves differently to a block that is defined like a block of the function itself.
Yeah.
It's because we're making mutations to variables that we're effectively passing into that block, I and j,
Yeah.
and those mutations are persisting. You're saying that those mutations
No,
are
no,
persisting
no, we're not.
beyond-
No, sorry. We're not passing I and j into the block, right?
Just sees them.
This is not a function we're declaring.
No, I understand.
This is
that
just
it's not a function. I'm saying that we're effective. That's what we're effectively doing, isn't it?
I would say that's probably not the right way to think about it. This is still the same I and j. We're not passing them anywhere. We're not copying them anywhere. We're not moving them anywhere. This I and j, these labels, these names, are those two variables.
Sure.
Right? They just happen to be still in scope. We have an inner scope that encompasses. Sorry, we have the outer scope which encompasses this inner one. So everything that was in scope in here is still in scope inside the
But
block.
what if that was a function, that block?
You just call.
If it was, you can't have inner functions like that in C++.
Okay.
Yeah, you can't. Well, we have lambdas, but you can't use the normal function declaration syntax like that.
If it isn't anonymous, if you have an if statement right before the second,
if
before
true.
the anonymous, if you have
If
an
true
if,
would be the
let's
same
say if something, if I is greater than
Yeah.
x, right?
Yeah. You could still refer to I and j inside the body of the if
I
statement.
think that's probably
Okay.
Yeah.
And they would. Okay.
But that is the same as having if true curly braces.
Right.
Yeah. That's the way of thinking about it. Yes. So why am I telling you about scopes? Firstly, because C++ is pretty strict about it, more strict than other languages have, some cases quite strange scoping rules. But it's because this notion of scopes is really important for memory management in C++. So historically, memory management in C++ was awful. Right, the stuff of legend. Back in the bad old days, C++ 98. And then the various changes that they introduced in C++11 made this much, much easier. It allowed us to write what are called smart pointers, which we will talk about in a future session. But the point is that, unlike other languages, C++ doesn't use garbage collection. Most of the programming languages you'll have used use some form of garbage collection. So Java, C#, JavaScript, Python, Swift, sort of. They all use some form of garbage collection. C++ doesn't. It's the programmer's responsibility to look after memory. But we do that using scopes. And this is a really, really important notion, sort of central to the way what we call modern C++ is done. It has this ridiculous acronym, RAII, stands for resource initialization. Resource acquisition is initialization, which is meaningless. Like, it doesn't tell you at all what it...
It does.
Anyway. But this idea of using... I prefer the term scope-based resource management. It's a bit of a mouthful. But it's really, really key to how we write C++ these days. So, when we declare a variable inside a function, that's called an automatic variable. There are some other types of variables. You can get static variables, thread local variables. Ones we really care about are automatic variables. And the reason for that is an automatic variable is destroyed when it goes out of scope.
So it's automatic in the sense that it's garbage collected without
garbage collected. So it's not. There's no other process. There's no background process that's going on looking after our memory. This is just the normal rules. So the normal rule for an int, when you hit the closing brace, that int is destroyed. But this also happens for any other type that you declare as an automatic variable. It's destroyed when we leave the scope that it's declared in. That sentence should have an S on the end. But anyway, function parameters are also automatic variables. So when we leave the function, by a return statement, or an exception, by just falling off the end if it's a void function, that also destroys the function parameters. And the key part of this last one is because we can have these special functions called destructors that run when a variable is destroyed. And that's really the key one. That's what allows us to, for example, close a file when we exit the function in which the file is opened. Hand some memory back to the operating system. This idea of scope-based resource management, destructors, and as we'll see much later, moving variables, really absolutely key to how we write C++. So this is why I'm introducing this pretty early, because it's a really important notion to get sort of get a firm grasp of. That's why I've been banging on about scopes. And normally you wouldn't care, but it's really important in C++. So this is going to be a very, very similar example to the one you've just seen, except now we're not talking about scopes, we're talking about lifetimes. So J's lifetime begins here. It's an automatic variable. Its lifetime begins when we declare it. I's lifetime began when we entered the function. Didn't write that, perhaps I should have.
Online users mentioned that your explanation was about RIII was excellent. They didn't understand until you explained it.
Oh, well, thank you. So now we create an inner scope. And we initialize k with j plus 1. And k's lifetime begins here, begins with its declaration. Bless you.
Thank you.
And now this is an if statement. If you haven't seen it before, don't worry, we're going to talk about it in a little while if we've got time. So this is an if statement. So if this thing is true, if k is equal to 1, then we return. We're returning void. This function has a void return type, so we can just say plain return. We don't have to return a value. Just do plain return. So if k is equal to 1, bail out the function at this point. And if we leave the function at this point, we leave this inner scope, and we leave the block scope of the definition. So all three of our variables that are currently in scope get destroyed. K, J, and I get destroyed, actually in that order. But that's if we return, but we might not return there. So if K was equal to something else, we'd skip that bit. So now we close this inner scope. And at this point, the closing curly brace, K's scope ends, K's lifetime ends. K is no more. And then we close our function definition. And at that point, I and J go out of scope, I and J are destroyed. Everyone's nodding.
So scope and lifetime are entirely equivalent or not?
For automatic variables, yes. That was sort of the point I was trying to drum home. Yeah. So automatic variables, their lifetime is entirely based on their scope. When we leave the scope in which they're declared, they get destroyed. So I throw in the added complication of this return to show that there is another way of leaving a scope beyond just hitting the closing curly brace. A function return is one of those ways. And again, later on, we'll see we've talked about automatic variables, which is 99% of the time. We do have static variables and thread local variables that exist as well, dynamic variables.
So the auto type.
Yes.
Is that the keyword auto?
The keyword auto changed meaning in C++11. So the keyword auto has been a keyword since the very earliest days of C. And way back and I'm talking like the early 1970s when C was first invented, auto meant this is an automatic variable. So you'd say auto int I equals 3. But auto was also the default. So nobody ever bothered writing it because why would you write an extra 5 characters, AUTO space? It's pointless. Nobody would ever write it. So nobody did. So when they came to do C++11, they wanted type inference. They saw that there was this spare keyword, auto, which was technically valid, but nobody ever used. So they changed the meaning of the auto keyword to mean automatic type, to mean an inferred type.
That has nothing to do with this auto whatever scoping that you're talking
Not anymore, no. That's where the keyword came from.
about. That is something that's truly confusing, I have to say, from my perspective.
Well, it's unfortunate. They go to quite some lengths to avoid inventing new keywords, and that was one that happened to be available. But yes, once upon a time, auto meant this is an automatic, this variable has automatic lifetime. It no longer does. But that's, once upon a time it did.
Implicitly, anyway.
Yeah.
A variable has automatic lifetime implicitly. So if you put auto in the old C++, it's a pointless thing to put because it would be anyway.
The only place it was valid, it was also the default, so they got rid of it. Well, they didn't. They changed its meaning. So, scopes and lifetimes. It's how we manage memory in C++, how we cope without having a very smart garbage collector that is constantly keeping track of what we're using and what we're not, and getting rid of the things we're not using. We don't have to worry about that. We hit the closing brace, the things we were using that we finished with disappear. They're destroyed there and then. Deterministic destruction. It's brilliant. Best thing about C++. How long have we got? 45 minutes or so. Whew. Should we move on? Talk about something completely different. It's not to do with scopes or lifetimes or variables or anything. Let's talk about if statements. We just saw one. It's really a basic building block of a program. I would say you can't do much without if. Oh, I can see it from my slides. It's looking different. That's all right. This looks okay on the screen. It looked pretty bad on my screen. We say if condition, do something. So if this condition, this expression, if it's true, then we execute this thing in the curly braces, the body of the if statement. So if the condition is true, we do that. Otherwise, we just skip straight to there.
Will it coerce a value to a Boolean condition? Pass it a value?
That's a very good. Yes, it's not called coercion in C++. It's an explicit conversion to bool. But if a type can be converted to bool, it will try very hard to do it.
Okay, so there is such thing as truthy and falsy values.
Again, yes, in a sense. So an int, you could put if I. Well, I is an int, and then for an int, 0 means false and any other value means true, for example.
Yeah.
So yes, there's a notion of truthy and falsy, but that terminology isn't used, but it's effectively the same thing. I don't know how well this is going to come out because it's looking terrible on my screen. But as you've probably seen in other programming languages, we can say else if. So first we test this condition. If that's true, we'll execute there, and we'll leave. But if this condition is false, we'll try this one instead.
Can you do multiple else ifs?
As many as you like.
Note that they're not joined up, unlike certain languages, because it does the same thing anyway. You don't join up. Like PHP, for example, right? It has else if as a keyword.
Oh.
But it's logically it's pointless. It does the same thing anyway.
So yes, you have as many else if statements as you like. And that was what I was seeing on my screen. I don't know what's happening. I've got to get better at using Keynote. But conditions are tested in the order that they appear. So first, this one is tested. Then, only if this one fails, is this one tested. And then if we had multiple, they would be tested in order. And the first one that passes is executed, and then we leave. And then we can have, no, I'm going to have to play with this, aren't I? Imagine there's a closing curly brace, because if I try and display it, the whole thing disappears. If anybody is an expert with Keynote, just please come and tell me what I'm doing wrong. Anyway, we can have a sorry.
So it's the get preset.
Start using PowerPoint like everybody else. Yeah.
Do you want marker?
Yeah, they'll really appreciate that on their nice white wall, won't they? Yeah, we can have this this else block that's, if none of the conditions hold, we do what's in the else block. So again, basically every programming language you will have used will have something very much like this, probably using the exact same keywords, probably using the exact same syntax. So this should be all reasonably something you're reasonably happy and confident about. Certainly on firmer ground than talking about value semantics and variable lifetimes, right?
Yeah.
Excellent. Because now you got the chance to prove it. Who's done FizzBuzz before? Who knows what it is? Yeah, it's a. Well, you did it last time we did this. It's a very common sort of programming language exercise, kata, some people say.
Interview question.
Sorry?
Interview question.
An interview question as well, yeah. So yeah, by the time you leave here today, you'll all be able to pass the C++ interview. if you haven't seen it before, the modulus operator. Sorry?
I was just saying, yeah, sorry. Yeah.
The modulus operator, this percent sign, we can use it with an int to get the remainder after dividing one int by another. Right, so we've got I is 16. I've declared as a constant, again, just to remind you that the const keyword exists because you haven't seen it before, you haven't seen it today. This means an int whose value can't change. So now we're saying if I percent 2, the remainder after dividing it by 2, if that is equal to 0, then we execute this. Otherwise, we execute that. The modulus operator, the remainder after dividing one by another. So think about it, if you divide something by 2, there are only 2 possible remainders you can have, either 0 or 1. So that's why we have those 2 cases. So we've got another exercise, because it's been a lot of me talking, and today I thought, I'll get you guys working a bit more. Because, as I was saying way back in week 1, the only way to get better at programming is by writing programs. It's no good reading a book about how to play the guitar. You need your fingers on the fretboard if you're going to be Jimi Hendrix. So there you have it. This time I've told you to use separate compilation, separate CPP and header file. Again, really, that's just because I wanted to remind you how to do it. We saw it last week. Repetition, practice.
Once you opened it once, you get the one thing before you should have made it before. Yeah. But now you read it, it still works. So it was the once about, I think. Yeah.
Couldn't wait half that. Couldn't wait half that. Any questions?
Usually, you had a compliment, so I passed that through a couple of extra poly. I wonder how many people will use switch case and so it was greater.
For this problem,
online.
You know how to use that, it's trivial.
Yeah, that's a bit more advanced than we're doing right now.
Here's your answer. If anyone got trouble, just lift your hand and we'll try to give you a hand. you okay? Do you need help? Divide is simply the module operator. So you put I as the variable, then you do modulo 2. Yeah. Open first. You need to open the gig. Is it okay? So first open the. You need to open the curly braces. You can do on this line or the next line, doesn't matter. The C++ does not really care about those white spaces. So you say if, open bracket.
Okay, so in FizzBuzz C++, we write
modulo
definition
2.
of FizzBuzz. Yep.
Now, equals,
definition of FizzBuzz.
so that means
in the header,
then 0. Yes. So
one
that just means reminder. So if let's say if you say I is 2, so 2 divided by 2.
Just executable, and then there's a menu option in C line to create a resource file.
Let's say 3. So 3 divided by 2.
I did do this as an example last week.
From 3, so you do 1. Yes. So go to the next line. Yeah, because these ints are full numbers, so it's not like floating numbers. Yeah. So go to the next line. There's curly braces.
Okay.
So let's do this. Yeah. So we're sending standard out.
Yeah.
C out. C out. And then STD is standard namespace. So all the standard, like keyword.
So technically, in this simple case, you don't need it in the implementation file.
You have
But it's
need to translate like C out,
because every declaration
compiler needs to
don't worry about this stuff.
You could use different libraries. That's the basic library.
I would say probably if you want to continue using the other one.
So that's referencing that particular library.
Yeah, so if I tell the compiler, you will find this thing, C out, this library. So it tells you where to go. So then it's extract operator, so we are sending something to the C out console. It's display information on your screen. What you see here, yeah, like it's what you see, you have printing access. I'm sending information to this one. Something from here and then say what it is. The second one we make keys and then go to
the other way to do it for this, you can use shared quantity. Be careful you don't get references.
Yeah. So then you go to this line here.
and it can kind of else. This is not a zero.
So in that case, you need braces. Instead of having less than right there, there's pointers. What pointers you just get is unique pointers. So then each node owns less than right trees. And when the node is destroyed, cursor be destroyed, all of the child.
Okay. If you have 6, yes, the I is 6. Yes. So how many 5s is 3? No, how many
That's the final state is nothing.
And you can go oh, sorry, yeah, you're
Yeah, one of those n-squared problems that you have to think hard about how to do it.
You cannot optimize
oh, you tested that.
I'm sure I have to sit down and read it properly and think about it.
Later we can use the debugger to apply one by one.
Can I ask you how you say any way to augmentation?
To do what? like yes, the marks. I mean, we try to by default, but you don't have to later on it's the tools that you can add extra things like a plan. Yeah, but you don't have it at the moment because that means you need to add like extra configuration. And you can use the plan to like along it is something which people if not for sea lion and plant ID. That's external tool which will help you.
STD
no, because that is available to everybody.
Later on,
just say and then you get
I know it's
Mine is really old. Right. Okay, I was forgetting this.
Yes, my car that is just to hold the 52 cards.
I still hear Laura. Say like, I run the door, like,
so because you didn't create a new project.
no, there are five.
So you need to create a new project.
No, so you have to, that's why you have to.
So that's why I have to create a new project so that it's new and completely separate. Because otherwise it's going to get confusing about how your if you want, you can just delete everything in this file and start again. So do you remember how to go to the file and
Oh yeah, that's
It's not seeing it as a single
source file. Here, I'll show you what it is. So now we've got a header.
yeah, that's perfect.
So this one is the definition of it. You're getting
Do you have a tutorial?
First of all, that's how we get it. So we're using this thing called standard you should say, do you want to add the right
I can just copy that.
Just underneath it.
Oh yeah.
Angle brackets, because we're going to. There you are. So type alternate. That is a line. So IO stream is the one we need to use this. See out, pencil out. So C line
Oh, that's good.
So now we need to fix this other problem. The name, it doesn't know what this function is. Why? Because remember from last week, we compiled. Okay, so that's why it says C. So we compiled two files. Yeah, we sent them to the compiler separately. This one, so we need some way of linking these things together, and that's what's happening. So in the header file, between these is some declaration about physics. Yeah, so I'm returning a string. Okay, so the other things we need for a declaration, we need to know the return type. And I get the resolution around the return type goes first. The return type is void, yes. And then we also need to know the parameters that it takes. You don't need to use that. Okay, so now if you try running it, how it's right.
Something, it can say something to do
But is that why you don't need to use your
for a basic program.
in the C file, you already use the CF. So one of the things you're trying to do is the CF. You're already using the CF.
now knows told us this one can exist.
And they can just explain it for us. Like, there's no way I would have been able to find it anywhere online. Yeah, or like some. I reckon there must be like
basically you should just do that now.
Because it's already happened. I did it differently. I actually. What do you mean? But look at your
So 15 should give you physical, and you're returning a straight and you return to the string. If you're looking at something, you actually have a sample. Exactly.
Because what's happening is inside your name, you're calling a function, and inside of the function, whereas if you
I just realised something.
I could understand it because it rounds it
It's like 0.7. You don't really understand it.
Modular, yeah. So all you need to do, you remember minus the remaining. So 5, dealing with integers, 5 divided by 4, once with remainder 1. Right? So the modulus operator gives you the remainder. So, for example, we have the example of something set 2 is the remainder when you divide by 2. So if there's no remainder, then that number is even. So 4 divided by 2 is 2. So remainder 3 divided by 2 was the remainder 1. So when you do it with 2, there are only 2 possibilities. But we can do the same thing if a number is divisible by 3. If we send 3, find the remainder. And that remainder is either going to be 0, 1, or 2. Because if we do 9 divided by 9 and send 3, we're going to get 0. There's no remainder. 10, we're going to get remainder 1. 11, we're going to get remainder 2. And then 12, we're going to get no remainder. No. So this is this is you're thinking about it in terms of sort of high school. You're thinking about it in terms of imagine you used to go, how many times, how many whole numbers, how many times can we apply this? Your whole plus the remainder. And then the modulus just throws the whole number bit away. So, yes, we have to, if we use the normal division operator, we have to worry about rounding. Modulo doesn't. It just returns the remainder after integer division.
So for example,
No, right, so I see where you're going from. So you, the modular operator percent side only works on you can't do like a 1.3%. You have to use a different function. It's percent sign only works.
So I have to, yeah, no.
I got I'm returning a string. No, it's because I was at the time I was returning a literal string. Yeah.
If you see your sequence, so it should have added it to this. So that's this is the configuration file. You know, I was talking about last week. This is why we want to select
Does it for you?
Yeah, definitely Tom. Okay, guys and girls, we've got about 15 minutes left. So, you've got a choice. I can either give you another 15 minutes to carry on with FizzBuzz, or I can start talking about loops. Do loops. Loops. Do loops. Do loops are one of the kind of loops that we're going to be talking about, funnily enough. This, by the way, was my solution to FizzBuzz. I got rid of the, if you use C-line, it would have put some include guards in there. I've just got rid of them because it didn't fit on the slide, but imagine they were there.
I tried to do something with concatenation with the fizz and the buzz, but it didn't quite.
There are as many solutions to this problem as there are programmers, I think. So if yours isn't identical to this, don't worry. As long as it works, that's all that we, just has to meet the requirements. But the key point I really wanted you to get was that you have to check for this 3 and 5 case first. Because if we check for 3 first, well, that's going to match, so we're not going to do any of the tests below that. So we have to do this case first. You might have done I%3 equals 0 and, sorry, I%5 equals 0 and I%3 equals 0 at the top there. Doing divisible by 15 is the same thing. 3 and 5 the code prime has to be, So that's my solution. I'm sure there are better ways to do it, but this fitted on a slide, just about.
Put your tests in a loop.
Sorry?
Put your tests in a loop.
In a loop?
Yeah, in a vector.
Oh, well, I could do that, I guess. But we haven't introduced loops yet. I couldn't really ask people to do that if they hadn't told them what they are. So we talked about if statements. Let's talk about loops. It's the other really fundamental building block. Again, without this, we can't really do very much. So really, a loop is just do this over and over and over until I tell you to stop. And just like if, C++ loop keywords are very similar to those found in other languages. Perhaps it's better to say it the other way around. Other languages have also inherited their syntax from C. So if you've used Java or C# or any of those curly brace languages, you'll already know about for loops and things like that. So this will all be revision. So the while loop is the simplest. Well, I think it's the simplest kind of loop we can have. So while some condition, do something. So the way this works is that we get to here, we test the condition. If that condition is true, we run this code. We get to here, we jump back up to the while again, we test the condition a second time. If it's still true, we run the loop. And we keep doing that until the test fails, until the condition fails. Again, probably pretty familiar stuff to a lot of people, right? And one thing to note is if we get here and some condition fails, we never execute the body of the loop, right? We'll just skip straight over it. Make sense? Yeah. That's in contrast to a do-while loop, which is pretty similar. We just write it like this instead. We do something whilst the condition holds. The difference here is we first execute the body, then test the condition. That's really the only difference. Oh. So the body here is something that will be executed at least once for a do-while. These are pretty rarely used. In fact, while loops aren't used that often, but do-while is particularly unusual. I just really included it for completeness. For loops, on the other hand, are used all the time, everywhere, by everybody, for everything, nearly. There are two ways of writing for loops in C++. The hard way and the easy way. So I'm going to show you the hard way. So for statement like this has 3 parts. As an initializer, has a condition, and it has the increment statement or expression. Again, pretty standard for a lot of programming languages that followed on from C, because this is C's syntax. So what happens is that we get here, first of all, we run this init bit, which is usually will be a variable declaration. Usually it will say, int I equals 0, maybe. After we've run that, we check the condition first, before we run the loop. So like a while. We check the condition first. So this might be int I equals 0. This condition might be that I is less than 10. Well, we've just said it's 0, so that's certainly less than 10. And after that, we run the loop. And once we get to the bottom, we run this bit. We run the increments, which would be, say, I++. Add 1 to the value of I. And after we've done that, we test the condition again. So now I is equal to 1. Well, that's still less than 10. So we run it again. And we run it again and again and again. Run the body, do the increment, test the condition, until the condition fails. So at some point, I is going to be, if we keep incrementing it, at some point I is going to be equal to 10. And at that point, we bail out. So every for loop can be written as a while loop if you want to do this initialization and increment bit manually. A for is just sort of a shorthand for writing a while loop yourself, really.
When I declare a variable, I don't remember, in C++, in init, does it live only in the scope of a for loop or not?
Very good. I had this example, and I was going to say exactly that. So the scope of I, the lifetime of I, begins at its declaration, and it lasts for the whole, in this case, for the whole of the 10 runs. That same I lives for the whole 10 runs of this loop. It exists until we leave the loop.
Okay, so bottom line, if I need a that variable that I use in the loop for some reason isn't even outside, I needed to declare it outside, otherwise...
Yeah, so if you wanted to save the value of I, for some reason, perhaps this had a break condition, so you could leave the loop early, then you declare it outside. It would still be in scope, because these curly brackets do form an inner scope, right? So we can declare a new variable inside the body, and it's not accessible from outside. The curly braces are a block, they form a scope, but it's a nested scope, so variables defined outside are still available inside it.
Also, the first and the third element of a for loop are optional. I don't remember the second, do you? The condition, can you skip the condition?
I don't think that you can, no. I think the condition is mandatory.
The first and the third?
You could always just put true in it if you wanted to.
Fair enough.
Sorry? Oh, no, of course it is. You can do for : semicolon, semicolon. Yes.
Okay.
It's implicit true.
Yes.
It's like doing a while true.
That is exactly it, except a couple of less characters. It's really important. Yeah. So that was the horrible old form of doing for. There are range for loops in C++ as well. So other languages have this as like for each. A lot of languages in C++, again, because we're averse to adding new keywords, it's a slightly alternative version of a for statement. So rather than the old form, it's not old, we still use it all the time. The 3-element form, we use semicolons. This one uses a colon. So for thing in range, do something. And now range, you can't just use any old type there. range has to meet certain properties. Has to be compatible with this syntax. Has to meet, well, I guess in other languages we call it the range protocol. It's supposed to call it the range concept. Fortunately, all the container types in the standard library, so vector, string, lists, set, map, they all meet this range protocol. So you can use them with this nice for loop, particularly for vectors. But this is not quite equivalent to the previous declaration. So on the previous slide, this I lived for all, one I lived for all the executions of this loop. That's not the case for a range for loop. Oh, so that's what I was saying about the protocol. So in this case, we're saying for int I in vec, so we've declared this vector containing 1, 2, 3, 4, 5. What's happening this time is, with regard to lifetime, slightly different. This time, a new I is declared every time we step through this loop. So it's very subtly different to the three element for loop. Keep wanting to call it the old one, which is a bit disparaging. It's still, as I say, still very useful all the time.
Even in this case, once I finish the loop, I doesn't exist anymore.
But again, it's still scoped to the for. So down here, there is no I. But I is created and destroyed, in this case, for every time we step through the loop. So in this case, vec has 5 elements, so we're going to run this 5 times, and each time we go through, a new I is initialized with the ith element of vec. So the first time we run it, we're going to get int I equals 1. And the second time we step through the loop, we're going to get int I equals 2. And the third time, 3, and so forth.
When it gets compiled, that is just syntactic sugar for using an iterator? Or
That's exactly what it is,
okay.
yes. Yeah.
So you should not worry about performance.
No. Yeah, this is...
Can you repeat that? I didn't know that.
Oh, sorry. So he was Giacomo was asking, is this the same as using iterators? Which is exactly what the range protocol I was talking about, yes. So
the range for is actually using it.
Yes, it is, yes.
Underneath,
hidden by the user, it calls begin and end and all those other things that if you know about C++ in the standard library.
This is exactly the same performance or whatever you write the iterator.
Exactly the same performance, yes. Yeah.
Which apparently is, for a vector, is still a bit worse than using an index. I check it some comparison.
I'm skeptical, but
yeah.
So what if you have, for example, what if you have a JSON that you want to loop over, so a hash table, and it has a bunch of properties, and you want to get the values for each of those properties?
Yeah.
So like in JavaScript, you have a for in loop, which is just another type of thing. But instead of having like a number, instead of getting each element out of that sort of set, we actually get the property name. Is there any sort of similar way of doing that in C++? Or?
So the equivalent of a hash table is an unordered map in C++. And you can use an unordered map with this, and what it returns you an object with the key and the value glued together. So again, in JavaScript terms, the key then would be the string, which is the property name, and the value would be its value. Right? So yes, if vec was an unordered map, then this thing here, instead of being an int, well, you probably use auto, to be honest, to save you typing it out, but it would be of type standard pair something.
Could you say sort that vec in the for? So if you needed a vector in a certain order,
you wouldn't be able to sort a vector with a for loop, because a for loop begins at the beginning, and goes to the end.
So you can't put in I, colon, sort, vec.
So there is a function in the standard library called sort, but what that does is it modifies the vector in place. It doesn't return a new vector.
Yeah, but so which vector would you be operating inside your for loop if you put the sort on inside?
Well, okay, so the sort function in the standard library returns void because it doesn't return a new value, it returns nothing.
Okay.
It operates on the vector in place. So if you said int I colon sort brackets vec, you're going to get an error because that function return of sort is void, it's nothing, so it's nothing certainly doesn't meet the range protocol. So
okay.
It's not going to let that compile. Yeah.
What happens if you try and mutate the range that you're going on while you're actually in the for loop?
Good question. Bad things.
Okay.
Yeah. Yeah. It's generally going to make a mess, and it's.
Is it like blocked, or is it like a race condition?
The race condition. And there's so in general, C++ lets you play with knives, right? Performance is everything. Nothing can get in the way of that, and you know, safety guards on the blade would slow you down. So, yeah, C++ lets you do dangerous things like modifying a loop, modifying a thing as we're iterating over it.
Wouldn't pick it up in the compiler then, because I would have thought that would be quite easy for it to pick up in the compiler. Or you're trying to mutate the thing you're iterating over, but it doesn't.
Right, but remember about separate compilations. So we might call some function that we pass value to, and it doesn't know the definition of that function, so it doesn't know whether that function mutates the thing. It would be nicer if we had more safety, but you know, if you want that, see Rust.
A static analyzer or sanitizers will.
Yeah, there are tools available that will check these sorts of things for you.
Also, how reliable are like a static analyzer?
Sorry?
How reliable are them? Can I feed my program to a static analyzer and be sure?
Yeah, so Clang has quite a good one. You wrap the build with it. So rather than calling Clang directly, I can't remember the name of it now, but you call that in front of the actual compiler command, and that wraps it and then gives you nice HTML output. I actually use it myself. Also, this isn't strictly a race condition, assuming it's just one single thread, but it would be UB. So you can mutate each element of I. So you can mutate stuff inside the vector, but if you, while you were iterating, you added an element, the vector might reallocate, so it's then gone and moved all the memory elsewhere, but your iterators don't know that. They're still pointing to the same place. So when you come around to doing more stuff with, say, the next element, or maybe you do more stuff with the same element, it's actually gone. It's gone elsewhere. Yeah. So now you get a crash.
Okay, so it's more than just it getting longer as it's going. It's actually changing.
Yeah, it has to. Usually, it has to reallocate. So it says, "Give me n+1," and the OS gives it a completely new space. So it then relocates, copies, or moves everything over to the new space, and then kills the old space.
Right, we're now 6 minutes over, and I'm surprised we haven't had anybody knocking on the door telling us to wrap up. So I did have another exercise, no time for it, never mind. If you want to do it, and I recommend it actually, I'll put the slides up when Lauren reminds me, wherever he is. We learned these things today, which was rather cool. Next time, references, const references, so all that stuff I was drumming into you about value semantics, we're going to go, okay, well, we can also have reference semantics, which work completely differently. Pointers, a bit scary, probably. If you did an introductory C course, you would have had pointers dumped on you right away, you would have gone, that's horrible. We don't often have to use pointers, but when we do, they're not scary. They're just values. But I'll talk more about that next time. As homework, if anyone wants to get a quick snap, told you we start using the book. Chapter 4 covers a lot of what we talked about today. The last exercise, well, we didn't have time to start it, never mind finish it. The end of chapter 4 has a drill, which I think is pretty good. And then chapter 7, jump right onto it. I think it's 7.2, just off the top of my head. Just introduced references and the syntax for it. But again, that's next week. And that's it from me. So thank you for coming. Cheers.
Thank you.
Okay, so as usual, everybody are welcome to go to the